Hello students, in previous lecture we have studied about the hydrolysis of three types of salts, that is hydrolysis of salt of strong acid strong base, hydrolysis of salt of strong acid weak base, and hydrolysis of salt of weak acid strong base. Then we are going to study about the hydrolysis of salt of weak acid weak base. All of you studied about that. Hydrolysis of salt of strong acid strong base does not undergoes hydrolysis. Then second type of salt, that is salt of strong acid weak base, it undergoes hydrolysis and solution becomes acidic. Salt of weak acid strong base, which also undergoes hydrolysis to gives solution, to make the solution basic. We are discussing about the hydrolysis of salt of weak acid weak base. Then let us consider there Ba is a salt of weak acid weak base, and when this type of salt dissolved in aqueous medium, that is dissolved in water, then salt of weak acid weak base compared with the acid formed here, that is HA is a weak acid and BOH is a weak base formed here, comparative with strength of weak acid and strength of weak base, the strength of salt is greater. Therefore, it is act as a strong electrolyte. Strong electrolyte comparing with the strength of weak acid and strength of weak base. Salts are more stronger. Therefore, Ba salt, that is salt of weak acid and weak base, in aqueous medium it dissociates completely. It dissociates more and more to gives B plus ion and A minus ions, whereas B plus and A minus ions both interacts with water, that is B plus ion and A minus ion in aqueous solution interacts with water to gives BOH and here HA, and therefore here the acid which is obtained here is a weak acid and the base which is obtained is a weak base. Then comparing the strength of weak base and weak acid, there are also three possibilities are there. See here, there are total three possibilities. Three possibilities are there for salt of hydrolysis of salt of weak acid and weak base. First one, that is, see here, if the weak acid, that is HA, is a weak acid which is stronger than the weak base BOH. That means here, if the strength of weak acid is greater, that is strength of acid is greater than the strength of that base, that means here HA, that is weak acid, but it has greater strength, HA is stronger then weak base, that is BOH. And for this purpose, therefore here Ka is greater than Kb, Ka of acid. Here acid is stronger than base, therefore the strength of acid and base which is considered for the strength of acid and base, strength of electrolyte, it is from Ka and Kb. That means strength of acid is measured from the value of Ka, that is dissociation constant of acid, and the strength of base which is depends upon the value of Kb of that base, that is the dissociation constant of base. If the Ka of weak acid is greater than the Kb of weak base, then that is the one of the possibility for the hydrolysis of salt of weak acid, weak base. Then the solution is acidic in it. The solution becomes acidic, that is the aqueous solution of salt of weak acid, weak base, it becomes acidic when acid is stronger than base. Then second one possibility, if BOH, that is base, is stronger than acid, Ha, acid, then here the dissociation constant of acid of weak acid is less than dissociation constant of weak base. That means here Kb is greater than K. Then after hydrolysis of that salt of weak acid, weak base, for which Ka is smaller than Kb, therefore solution becomes basic in nature. And when the third possibility, that is if dissociation constant of weak acid is equals to dissociation constant of weak base, then the solution which containing the concentration of hydronium ion equals to concentration of OH minus ion. Therefore, the solution is neutral in nature. Neutral in nature. Then, see here, we will discussing about the hydrolysis of salt of weak acid, weak base by taking 3 different examples for which these 3 different conditions are maintained. Then, first of all, we will discussing on the hydrolysis of salt of weak acid, weak base, for which Ka of weak acid is greater than Kb of weak base. Taking one of the example of this type of salt in which Ka, that is dissociation constant of that weak acid, is should be greater than the dissociation constant of weak base. And here, for example, NH4F, that is ammonium fluoride. Ammonium fluoride is the salt of, it is a salt of weak acid, weak base. Then NH4F, that is salt of weak acid, weak base, dissociate to gives NH4 plus F minus ions, and that NH4 plus ion as well as F minus ion both undergoes hydrolysis or both reacts with ions of water, and that NH4 plus ion it reacts with OH minus ion to gives NH4OH, that is weak base, and F minus ion interacts with H plus ion to gives HF, that is weak acid, that is hydrogen fluoride and ammonium hydroxide formation takes place. But here the Kb of NH4OH, that Kb for NH4OH is 1.8 into 10 raised to minus 5, and Ka of HF is 7.2 into 10 raised to minus 4. Then see here the degree of 10, that is index of 10 is here minus 5 and here minus 4. Therefore, this value for HF is greater than this value of NH4OH, that is weak base. That means here, by observing the values of Ka of HF and Kb of NH4OH, here Ka, that is dissociation constant of HF, is greater than Kb of NH4OH. That means here HF is slightly stronger. HF is slightly stronger. HF is slightly more stronger than NH4OH. Therefore, here, as both acid and base both are weak in nature, therefore the ions which is formed when ammonium fluoride dissolved in water, then it gives, that is NH4F, that is salt, aqueous solution of salt. It dissociates to gives NH4 plus F minus in aqueous medium, and here NH4 plus ion, that is cation of that salt, it interacts with OH minus ion of water, and it gives NH4OH, as well as here F minus ion, that is anion of that salt, NH4F salt, ammonium fluoride salt. It also interact towards hydronium ion, that is H plus ion, and it gives HF. See here, the OH minus ion of water here interacts towards NH4 plus to gives NH4OH and plus hydronium ion, because here OH minus ion of water reacts with NH4 plus and H plus ion reacts with another water molecule to gives hydronium. Similarly, the F minus ion in aqueous medium, it interacts with H plus ion of water. Then see here, H plus ion of water to gives HF with the formation of OH minus ion. That means here, when salt in aqueous medium dissociate to gives NH4 plus ion and F minus ion, then both ion have tendency to react with water. That means NH4 plus ion have tendency to react with water. That means NH4 plus ion undergoes hydrolysis to gives NH4OH plus hydronium ion, as well as F minus ion also have tendency to react with water to gives HF and OH minus ion. But here the NH4 plus ion interacts with OH minus ion of water and gives NH4OH, and the H plus ion which is formed here, which reacts with water to gives hydronium, and here F minus ion interacts towards H plus ion of water and it gives HF, and OH minus ion formation takes place here. But here NH4 plus ion has more tendency to interact with OH minus ion of water, and therefore it gives H3O plus, that is hydronium ion. That means here NH4 plus ion get more hydrolyzed than F minus ion, and therefore the solution, the resultant solution, that means the solution of NH4F salt when dissolved in water, when ammonium fluoride salt dissolved in water, then that resultant solution which gives, that is hydronium H3O plus ion as well as OH minus ion both. But here NH4 plus ion get more hydrolyzed than the F minus ion. Therefore concentration of H3O plus is greater than the concentration of OH minus ion in the salt solution of ammonium fluoride. As hydronium ion concentration is greater, therefore the solution of salt is acidic. That means here NH4F like salts undergoes hydrolysis because the solution of this type of salt is acidic. Then see here, one more possibility is there, that is hydrolysis of salt of weak acid weak base, for which Kb or Ka is less than Kb of weak base. Then taking one of the example of salt of weak acid weak base, for which Ka of weak acid that is dissociation constant of weak acid, is less than the dissociation constant of base, that is Kb, from which salt is obtained or formed. Then example of this type of salt, that is salt of weak acid weak base, for which Ka of weak acid is less than the Kb of weak base, that is NH4Cl. And the hydrolysis of NH4Cl, that is ammonium cyanide. Ammonium cyanide, it undergoes dissociation completely to gives NH4 plus Cn minus n in aqueous medium. But the NH4 plus ion, it interacts with OH minus ion of water and it gives NH4OH, and the Cn minus ion interacts with H plus ion or hydronium ion to gives HCl. Then see here the aqueous solution of NH4Cl, that is NH4Cl salt dissolved in given amount of water. Then it dissociates to gives NH4OH, that is weak base, and HCl, that is hydrogen cyanide, that is weak acid. Then here Kb of that weak base NH4OH is 1.8 into 10 raised to minus 5, and the Ka of weak acid, that is HCl, is 4 into 10 raised to minus 2. See here the degree of that 10, here degree of 10 of HCl is here smaller. Therefore the here Kb, that is dissociation constant of NH4OH, is greater than Ka, that is dissociation constant of HCl, that is hydrogen cyanide. That means here the base, that is NH4OH, which is a weak base, but as well as HCl is also weak acid, but strength of NH4OH is greater than the strength of HCl. Therefore NH4OH is stronger than HCl, that is weak acid, and therefore as here ammonium cyanide is salt of weak acid weak base, then the ion which are formed here, that is see here NH4Cl, in aqueous medium it dissociates to gives NH4 plus Cn minus. Then both ions have tendency and to undergo hydrolysis or to react with water, and therefore NH4 plus ion have tendency to react with water, HOH, that is water. It reacts with OH minus ion of water and it gives NH4OH plus H plus ion, which reacts with another molecule of one more molecule of water to gives hydronium ion. And similarly the Cn minus ion, which have also tendency to react with water, and it interacts with H plus ion of water, and it gives HCN plus OH minus ion. And here the resultant solution, that means aqueous solution of ammonium cyanide salt, that means ammonium cyanide salt when dissolved in water, then that solution which containing both ions, which containing H3O plus ion and OH minus ion, both ions. But see here, the Kb for NH4OH is greater, but here Kb for NH4OH is greater than Ka of HCl. Therefore, here NH4OH is stronger than, it is stronger than HCl. Both are weak, but NH4OH is slightly stronger than acid. Therefore, here Cn minus ion has more tendency. Therefore, Cn minus ion has more tendency to reacts with or interacts with water to gives more and more OH minus ion. That means here the concentration of H3O plus, that is H plus ion, is less than the concentration of OH minus ion, because here Cn minus ion undergoes hydrolyzed more than NH4 plus ion. Therefore, the resultant solution, it is basic in nature or alkaline in nature, and therefore it is said that salt of strong weak acid weak base, that is for which Ka is smaller than Kb, that is salt of aqueous solution of NH4Cl, that is undergoes hydrolyzed because solution is basic in nature. And then the third one possibility for this type of salt, that is here Ka is equals to Kb, that means the strength of weak acid and strength of weak base are same, from which the salt of weak acid weak base is obtained here. Then see here, hydrolysis of salt of weak acid weak base, for which Ka of weak acid is equals to Kb of weak base. That means here the strength of weak acid and weak base both are equal, from which that salt of weak acid weak base is obtained. And here example of this type of salt is CH3COO NH4, that is ammonium acetate. Ammonium acetate is a salt of weak acid, weak base, in which Ka of weak acid is equals to Kb of weak base. Therefore, here ammonium acetate, that is salt of ammonium acetate CH3CONH4, dissociate in aqueous medium to gives CH3CO minus plus NH4 plus in aqueous medium. Then see here the dissociation of this salt in aqueous medium. It gives CH3CO minus, which reacts with H plus ion of acid, H plus ion of water to give CH3COH plus NH4 plus ion interacts with OH minus ion to give NH4OH. Then here the acid which is obtained is a weak acid and the base which is obtained is a weak base. See here the dissociation constant for this acid is 1.8 into 10 raised to minus 5, as well as the Kb for, that is dissociation constant of base for NH4OH, is also 1.8 into 10 raised to minus 5. Then that means here Ka is equals to Kb, that is dissociation constant of acetic acid is equals to dissociation constant of ammonium hydroxide. That means both acid and base which is obtained here after hydrolysis of salt of weak acid weak base, that is aqueous solution of ammonium acetate, are equal. The strength of weak acid and strength of weak base are same. Therefore, here the Ka is equals to Kb for weak acid and weak base. Therefore, here the ion, that is CH3 COO minus ion, which have tendency to react with water. That means here the acetate ion which is obtained by hydrolysis of that salt, and that CH3CO minus ion interacts with acid to gives CH3COOH plus OH minus ion. That means here acetate ion, anion of salt, reacts with H plus ion of water and it gives acetic acid plus hydroxide in aqueous medium. Similarly, NH4 plus ion have also tendency to interact with water molecule, and NH4 plus ion, it reacts with OH minus ion of water to gives NH4OH, that is ammonium hydroxide, that is weak base, and with the formation of hydronium ion. That means these both ions have same tendency to interact with water, ions of water, to gives OH minus ions and hydronium ion. Therefore, the solution of ammonium acetate which contains that solution of salt which contains both ions, that is OH minus ion and H3O plus ions. And here in the aqueous solution of ammonium acetate, which contains the equal concentration of hydronium ion and OH minus ion. Therefore, the equality of the hydronium ion and OH minus ion in the solution, it does not get disturbed. Therefore, the resultant solution is neutral, and therefore this type of salt does not undergo hydrolysis, and that is about the hydrolysis of salt of weak acid, weak base. Then the next concept, which is related with the ionic equilibrium and different types of acids as well as base and different types of salts related with the acid and base. That is the one more concept related with ionic equilibrium, that is buffer solution. Then see here, what is buffer solution? Buffer solution is nothing but it is a solution of substance which resist to change in pH of that substance when small amount of acid or base added into it, or even after dilution. Dilution means addition of water. That means, see here, suppose there is a solution of particular substance and that solution which having a definite pH, any solution of any substance which having a specific, a particular pH. That means, see here, the pH of that aqueous solution of that substance, it changes if acid is added into it. That means, suppose BA is a salt and aqueous solution of that salt formation takes place here. Then that aqueous solution of BA salt which having a definite pH. But if we add acid into it, then what happens? When acid is added, then H plus ion or hydronium ion increases and pH of that substance decreases. That means solution becomes more acidic. And pH decreases. And if we add base into it, base, that is strong base like NaOH or KOH, when added into the aqueous solution of that salt solution, then here OH minus ion concentration increases and pH of that substance or that solution increases and solution becomes more basic. That means here the pH of the salt solution changes when small amount of acid or small amount of base added into it. You are aware of that in previous standard. Then even we added water into it. If water is added into it, then solution becomes dilute, and as solution becomes dilute, then pH of the substance, pH of that solution changes. That means here the pH of any substance in its aqueous medium changes with even after addition of small amount of acid or base or addition of water. That means after dilution, pH of that substance changes. But see here, buffer solution, it is a solution which resists to change in pH. Resist to change in pH means it opposes to change in pH. That means suppose if it is a buffer solution, suppose it is a buffer solution and pH of that buffer solution is a particular or specific pH of that buffer is there, and if we add acid into it, small amount of acid or small amount of base is added into it or water is added into it, that means dilution of that buffer solution takes place. Then even after addition of base or addition of acid or addition of excess water into it, pH of that buffer does not changes. That means it restricts, it opposes to change in pH. Then that solution are called as, that solution is called as buffer solution. That means here buffer is the solution of which pH of that solution remains constant for longer time, as well as even after addition of small amount of strong acid or strong base or even after dilution of that buffer solution, it does not change its pH. Though acid is added into it or base is added into it or water is added into it, that solution is called as buffer solution. Then according to definition, we can write properties of buffer also. Properties of buffer solution, that is, see here, properties of buffer. First one, buffer, that is pH of buffer, pH of buffer does not changes if small amount of strong acid is added into it. Second one, that is pH of buffer does not changes even after small amount of strong base added into it, or pH of buffer does not changes after dilution. Dilution means when water is added into it to make that solution dilute. Even after dilution. And pH of the buffer does not changes even after it kept for longer time. Kept for longer time. That is the properties of buffer. Then we will discussing on there are different types of buffers. That is types of buffers by taking or considering examples of buffer solution. See here. Then types of buffer. Then see here, there are generally two types of buffers are there. That is first acidic buffer. Acidic buffer. And second one, that is basic buffer. Then see here, the acidic buffer. What is acidic buffer? Acidic buffer is nothing but it is a aqueous solution of weak acid and salt of its strong base and its salt of strong base. That means see here the wording its is used. That means here aqueous solution of weak acid, that is for example CH3COH is a weak acid and its salt of strong base, its salt of or its strong salt. That means the salt which should be strong, that is CH3CONA, and the word it contains or meaning of that it is that strong salt which containing same ion which is present in the weak acid. That means here CH3COO minus ion is common there. That means here what is acidic buffer? It is an aqueous solution of weak acid and it means the acid containing ion that should be there in the strong salt. That means here example acetic acid plus sodium acetate, and here sodium acetate is a salt of weak acid strong base. Therefore that salt is strong salt which containing common ion. Acetate ion is common in those weak acid and salt. Similarly, one more example, that is HCOOH, that is formic acid, and HCOOK, that is potassium formate, which containing the same ion, that is here HCO minus ion is there. Similarly, one more example of acidic buffer, that is HCO3 minus ion plus H2CO3. That means see here H2CO3 is weak acid, carbonic acid, and HCO3 that is here NaHCO3, NaHCO3, which containing HCO3 minus, and here weak acid also contains HCO3 minus. That is the few examples of acidic buffer, as well as we will discussing on basic buffer by taking few examples of basic buffers. Then second one, that is basic buffer. Then what is basic buffer? Basic buffer is an aqueous solution of weak base and its strong salt, similar like acidic buffer. Acidic buffer is a solution of aqueous solution of weak acid and its strong salt, like that. Basic buffer is also solution of weak base and its strong salt. For example, weak base, that is NH4OH plus NH4Cl, which containing common ion. It means common ion is present between weak base and that salt. NH4 plus ion is common ion. That is about the acidic buffer as well as basic buffer. Then the pH of these buffer does not changes even after addition of strong acid into it or strong base into it, or even after dilution. If that buffer solution get diluted, pH of that buffer solution does not changes, or that buffer solution kept for longer time, then pH of that buffer solution does not changes. Therefore, because of this property, that buffer has wide variety in everyday life. Then see here, pH of acidic buffer as well as basic buffer can be calculated or determined by Henderson, Hazelbach equation. That equation is used to calculate or to determine the pH of acidic buffer as well as basic buffer. Then Henderson-Hazelbach equation for acidic buffer. That is pH of buffer is equals to pKa value. That is pKa like pH, as pH is equals to negative logarithm of H plus ion. All of you understand about that, or all of you studied about that. Like that, pKa value, that is potence of K, dissociation constant of acid, is the negative log of K to the base 10. Then pH is equals to pKa plus logarithm of concentration of salt upon concentration of that weak acid from which that acidic buffer solution is obtained. For example, for CH3COOH plus CH3COONA acidic buffer, the pH of that acidic buffer is, the pH is equals to pKa plus log of, here salt is CH3COONA, acid, that is CH3COOH. Therefore, here log of concentration of salt, that is CH3COO Na upon concentration of CH3COOH. Then see here, salt is strong, therefore it dissociates into CH3CO minus into concentration of Na plus. That is the pH of acidic. Similarly, we can determine the equation for basic buffer. Basic buffer, that is pH of that basic buffer is the pKb plus log of concentration of salt upon concentration of base to the base 10. Similarly, here pKb is the negative log of Kb to the base 10. Then here, for example of basic buffer, that is NH4OH plus NH4Cl, aqueous solution of NH4OH and NH4Cl. Therefore, Hazelbach equation for this basic buffer is pH is equals to pKb plus log of concentration of, here salt is NH4Cl, but NH4Cl is a strong salt, it dissociates into NH4 plus N into, that is Cl minus, concentration of Cl minus N upon concentration of NH4OH. That is the Henderson-Hazelbach equation is used to determine the pH of acidic buffer as well as basic buffer. Then in next lecture we will discussing about the buffer action, that means mechanism of buffer and applications of buffer. Thank you.